Welcome to our Big Data Analytics Group project presentation on behalf of Carolina, John Tao, Una, Yukon, and myself, Robert. Welcome and thank you for your time. We'll be covering insurance policy project today. So this is from the perspective of a car insurance company who has managed to get customers onto its site who are reviewing different policies and deciding which, if any, they will purchase. The purpose of the project itself is to develop a recommendation system which would efficiently and correctly recommend suitable insurance policies for these customers. The benefits to the customers of this are a shorter decision-making process and increased satisfaction. And for the car insurance company itself, improved knowledge discovery, and most importantly, an increase in revenues by making sure that more customers purchase policies rather than simply look and then leave without making a purchase. So our objective is to apply algorithms with advanced technical tools to predict which policies clients are willing to purchase.
So we got our data set from Kaggle, and the data set came in 2 files, and one file has the training data set, which has 97,009 unique customers, and the other file has the test data set, which has 55,716 unique customers. There are 19 variables in the data sets, but we are only using 4 for our models. They are customer ID, shopping point, record type, and the policy options, which are labeled as A, B, C, D, E, F, G, and each option has 2 to 4 possible values. Next slide, please. And the first step we did for our data pre-processing was that we split the training data set into 2 subsets based on if a customer has purchased the policy or not. And we and for the data engineering, we combine the possible values for each options into a policy ID. So we can use that ID to identify uniquely identify the different policies. And we also created likely score, PageRank score, and transition matrix with conditional probabilities for each of our models.
For our system design, so we started from our trained data set that had the reviews from the customers. From there, we trained 4 models: popularity, collaborative filtering, PageRank, and Markov. From the iterative algorithms such as LAS and also for PageRank, we use PySpark computer framework and as well as for building Markov Chain. Finally, the test data set that included the final decisions with the purchase decision of our client, we used it to test the accuracy of the 4 models we built. So the first model is popularity. This is a simple model where we just extracted all the policies that were reviewed, and we count them and we rank them. And there we got the top 10 result for the most popular policies. We can see that reviews distribution is a normal distribution where each customer review at least 3 policies before making a decision, and on average, customers review near 6.8 policies before making a decision. For collaborative filtering, as mentioned before, we need some data engineering because we didn't have the ratings for the policies, so we had to infer them from the customer's behavior. So we assume that the more a customer review a policy, the more likely that customer is to purchase that policy at the end. So our likely score is the times that a policy was reviewed over the total policies that the same customer reviewed. So that likely score that we built has we can see the histogram distribution on the right, and it has high concentration of ratings below 0.4. That is something reasonable that we expected to happen because, as said before, customer review on average 6 policies before making a decision. For building the model, we tested a range of iterations from 5 to 15, and then we concluded that the model with 15 iterations was the one that was performing better and the one that had the least minimum squares. So we used that model to input our data, that is the train data, and to get the output for the top 10 recommendations per customer. I would like to highlight here that our input data was for 97 unique clients, and the output data had only 80,000 predictions for customers. This is mainly because for those customers that only review one policy, the model was not able to make a prediction in that situation.
And for the third one, we have implemented the PageRank recommendation. Since the review process of each customer applies a time series, and a customer review a policy, the next movement could be review the same policy, or switch another policy reviewing, or finally cover the policy. So based on this, we constructed a chain of policies based on how the customers switch from reviewing one policy to another. And we use this chain to build the PageRank map. And we use the RDD MapReduce to calculate the PageRank scores with 8 iterations of the PageRank score convergence. And for the final recommendation, we just orbited the policies the customer reviewed as the starting node, and we find the linked end node as the top 10 PageRank scores as our recommendation list. But unfortunately, the model performed not as well as we expected before. Next slide, please. So we improved the algorithm by implementing the Markov Chain recommendation. First of all, the Markov Chain is a conditional probability, which means the current event happened, it's only relying on the previous event. So based on this, we just construct a transition matrix as we can see below. For each cell, the Pij represents the probability when I happened and the j will happen. So Pij equal to the number of times from I to j at time t1 divided the total times I appear at t0. Based on the transition matrix, we only use a customer's first review policy as the current event and recommend the top 10 highest probability next policies to these customers. And this model performed much better than the previous one. So, and final, my teammates will introduce the evaluation and the result.
So for the descriptive analysis, we first performed the popularity analysis, and the first two graphs represent the popularity distribution per policy. On the left, we have the most reviewed policy, and on the right, we have the most purchased policy. And we can see that both graphs have long tails with top 200 policies representing nearly 80% of the total reviews and purchases. And for the third graph, we have the curve representing how the probability of a customer that will purchase the policy based on how many times have the customer reviewed the policy. So we can see that the higher, the more times a customer review the policy, the higher probability that the customer will purchase the policy. Next slide, please.
So here you can see the predictive results we got from our models. Overall, collaborative filtering, user-based, and Markov chain have the best performance. However, both have certain limitations. Collaborative filtering has limitations when giving recommendations to new customers because it strongly relies on the client's ratings and past review history. While on the other hand, Markov chain is limited in the sense when the new policies are introduced or when regulations change, because in that case, the transition matrix needs to be rebuilt based on the customer's new review data. So based on the performance and limitations, our final recommendation would depend on the opportunity cost of building the algorithm learning curve during a single contact with the client. So if there is a risk of losing the client before reaching a threshold between 3 to 6 policies reviews, we wouldn't recommend to apply collaborative filtering. Instead, we would recommend Markov chain. So to conclude, in a short run, we would recommend for the company to implement Markov Chain model, but in the long run, in these turbulent markets, we would definitely think that that a CF model can give better results. And for the future research, we would try to find a way to combine both models together for a more comprehensive recommender system. Thank you for your question. Thank you for your attention.